We're going to find some descriptive statistics. In particular, I want to look at the mean and the standard deviation. So the mean, use the symbol usually X bar for that, is the sum of the data values divided by the count. So each data value is called an X value. We sum up those X values, divide by the sample size. That's also called the average. Standard deviation, it's a measure of an average measure of the distance of the data values from the mean. So here I have a particular X value, I subtract the mean, I square it, I add that up for all the data values, divide by n minus 1 instead of n, take the square root of all of that. That's the calculation for the standard deviation. What's important about that is I'm looking at how far each data value is from the mean, and I'm doing this other bit of fancy math around it to calculate a kind of average. Turns out this is the best way to average how far each number is from the mean for a data set. The best way to do it is to not use that formula, but to just use a spreadsheet or some other app like StatKey that does it for you. So let's look at this for a data set, and then again, look at that idea of average distance from the mean. So I have some data here about the pounds per square inch, the strength of concrete, and I want to copy these numbers and put them in my spreadsheet. And every spreadsheet does this the same way. I'm going to use Google Sheets. Excel works the same way. Now I'm going to find the mean, and I'm going to find the standard deviation. And so the mean is just the average. If the only thing in that column is maybe a title and the data, you can select the whole column. I get 4,209.4. If you're unsure about what else is in the column, then just select the exact values that you need to work with. In this case, I'm going to get the same value. Standard deviation equals, start typing STD, and you get a bunch of standard deviation options. You want the .s version, and select your data. If that's the only thing in the column besides the title, you're okay selecting the whole column. Alternatively, you could just select the specific values. And either way, I get the same number. One's rounded a little bit different, but they're the same number. Here I chose to round to 1 decimal point because these are whole numbers. You could show more decimal points if you need to. Up to you on that one. So here, what I'm finding is that the average strength of the concrete is 4,209.4 psi, and the spread, the distance from that 4,209 on average is about 188, right? None of these numbers are exactly 4,209.4. How far are they from 4,209 on 4.4 on average? They're about 188 psi from that middle number on average. Let's look at that graphically. So I'm just going to highlight that column, make a quick histogram. Google says, here's a quick histogram. Sometimes it does a good job, sometimes it doesn't. I'm going to redo that. Let's try with a bucket width of 50. I'm just guessing, starting at, I'm going to say 3,900. Looks like about a good place to start there. All right. So if you're not sure where to start, you should definitely calculate the min of the data set. So I'm going to do that here just to be safe. Min is 3,913, so I'm safe starting at 3,900. All right, so this is the distribution of data there. So the next thing I want to do is just draw on that a little bit. So I am going to copy this sucker, and then I'm going to draw on it right here by inserting a picture, a drawing of itself. All right, so the mean was around 4,200. So I'm just going to round it to that value. I'm going to use my little squiggle tool here. So the mean is about right here. So this right there is my X bar. And let's pick a different color maybe. How about red? X bar. Let's make it a little thicker. So that's the 4,200. The standard deviation was about 188, so let's call it 200. So that means on average, I expect numbers to be within 200 of that right there. So some are farther, some are closer, but on average. So if we go 200 from that, that's going to be about 4,400, which is over here-ish. So somewhere over here is one standard deviation to the right. So if I take X bar, the mean, and I add to it the value of the standard deviation, usually we call that S, that puts me right here. I could also go the other way. That's going to put me over here at about 4,000. So that right there would be the mean X bar minus one standard deviation. Now I could go two standard deviations to each side. So that would be somewhere over here, 3,800. So that would be the mean minus two standard deviations. And I could, again, add that, put me over here at like 4,600, slightly off the chart. That would be X bar plus two standard deviations. And what we usually expect to see is around 95% of the data is going to be within two standard deviations of the mean. Within one standard deviation, there's a lot more variation on data, so I'm not going to put a number to that. But again, what is the standard deviation? It's the average spread of all the numbers from the mean. How should you calculate that? You should use a spreadsheet or some other bit of technology to make the calculation. So I'm going to show another bit of technology to do that. So with the data copied, search for an app called StatKey. That should take you to this home page here. We're messing with one quantitative variable. Use the Edit Data button, delete their data, and paste in your data. Oops. Yes, the last thing I copied was the spreadsheet, which StatKey doesn't want. Let's try that again. There we go. So there's my data there. Does it have a first column identifying each number? The answer is no. Does the data have a header row? The answer is yes. So make sure you check those boxes appropriately. Click OK. StatKey will then calculate the sample size, the mean, the standard deviation, and the 5-number summary, which is pretty cool. They show a dot plot of the data here, and they'll also give me a histogram if I want. So similar but different than the Google one, because this one has a different starting point and a different width to the buckets. So if I wanted to, I could say with this, start at 3,900, go to 4,500, and give me 12 buckets. I think Google had 10, and I tweaked them just a little bit. So there's another version of a spreadsheet. The middle of this spreadsheet, according to the mean, is 4,200. According to the mean, it's 4,240. So it's a little bit, the median's a little bit higher, the mean's a little bit lower here. And that varies from data set to data set. StatKey agrees the standard deviation is about 188. I called it about 200. And again, that's the average spread from the middle. Bottom line, standard deviation is the average distance of the data values from the mean. You should use technology to calculate it. It's an important number for descriptive statistics.